Okay folks, here we are in the final video for chapter 2. This is going to be 2.2.5 equations in graphing form for families. So we're looking at families of functions here. Those parent functions, how the parameters affect them. This is all stuff we've talked about before. We just want to kind of summarize what we know already, and make sure that we've really internalized all of this stuff because it's pretty powerful. So let's take a look at it. If we have the function y equals f of x, and that's an equation for a parent graph for one of our families of functions, then when it's in graphing form for the family of functions with similar characteristics as f of x, it can be written as y equals a times f of x minus h plus k. We're going to call h and k locator points. So that could be the vertex of a parabola, or it could be a point on a line in point slope form, or one of the other locator points for the other families of functions. Because it helps us to locate the transformed graph. These parameters transform the parent graphs as follows. So anytime we add or subtract something from the x, which is what's happening with our h value, that's going to shift our graph back and forth. It's going to horizontally translate our graph. Our k value, which is actually being added to our y, but we move it over to the other side, shifts our graph up and down. Our a value, depending on whether it is greater than 1 or less than 1, between 1 and 0, it's either going to stretch it if it's greater than 1 or compress it if the absolute value of a is less than 1. Okay? So it adjusts the steepness and the stretch compression factor. That's what gives us tall skinny parabolas versus big open parabolas. It adjusts the location of that y value. Okay? And if the a value is negative, we get a reflection across the x-axis. So it gets flipped over the x-axis if we get an a value that is negative. All right? So these are all things that you've seen before, but you do need to know what they all mean. And the real trick here now is applying it to any family of functions. You've seen it in a bunch of specific applications. Now we want to be able to use that for any family of functions. So let's take a look at our parent equations and our families of functions, and then the graphing form that goes along with each of those. At this point, guys, I would go ahead and ask that you pause the video, write these down in such a manner that you can go back and look at them later, okay? Also, at the very top here, I said see learning log 1-33 because that was one of the first learning logs for the year, and that relates to these families of functions and to these parent functions, okay? So, what do you need to do after the video? Explain what each highlighted parameter does to the family of functions there, and just write the equation, then tell me what each of the highlighted parameters does to that graph, and be ready to talk about it next class. All right, thank you folks.